Ladies and gentlemen, good afternoon. Thank you for being here today. My name is Dr. Suhair AlTheraa. I have a PhD in mechanical engineering. I have 7 years experience in robotics engineering. I am the principal investigator of the RESS project and a project manager. And the RESS project is the abbreviation of Robotics Engineering Simplified in Iraqi and UK schools. First of all, I would like to take the opportunity to express my sincere gratitude and thanks to His Excellency Dr. Suhair AlTheraa, the Ambassador of the Republic of Iraq in the United Kingdom, for his hospitality in the very special place, for his continuous support, and I also would like to thank the embassy, all the embassy staff. I wish to express my sincere gratitude and thanks to the Cultural Counselor, Professor Musa Al-Musawi, at the Iraqi Cultural Attaché, the official representative of the Ministry of Higher Education and Scientific Research in the United Kingdom. Thank you very much for the support and help you provided, for your dedication, attention, and open-minded thinking, and for your readiness to help with the very prompt response to requests. Thank you for opening this door of opportunity, which is a huge step for me, and for giving me strength to resist and succeed. Thank you very much for everything. I would like to thank the Iraqi Cultural Attaché staff in the United Kingdom for their kindness, generous, caring, and giving. Thank you very much. It's my great pleasure and honor to welcome Mrs. Adriana from the Women Engineering Society in the United Kingdom. Also, it is my great pleasure to welcome the former president of Al-Kindi Society for Engineers, Mr. Muntazar Tariq Najm. I also wish to extend a warm welcome to all our guests. Thank you to our speakers and participants. I hope the discussion today will inspire us all to respond effectively to the challenges and opportunity ahead of us. It's my pleasure and privilege to welcome you all today. Coming to the work of the meeting, I would like to start with my patent of the RESS project. This project is my patent. It's an idea from my head. It is not related to my PhD. Okay, so why the RESS project is important? The nation is hoping for a brighter future. Engineering is central to economy development of every nation, creative and dynamic. There is a widespread international concern to improve the number of peoples in the engineering field, and the key strengthening to the economy lies in fostering an innovative culture and educating the youth. According to the figure, a survey presented by King College London 2013 found that the top 5 most popular aspirations in Year 6 children and Year 8 as shown. Sports, 16%, 13% aspires for art, 10% teachers, 8% doctor, 6% vet, 20% arts for Year 8 children, 10% doctor, 9% business, 9% sports, 6% teachers. And for engineers, 0% for Year 6, 0% for Year 8. Children have zero ambition to be an engineer in the future. Another figure is a percentage of students aspiring to jobs. And this percentage based on a sample of survey responses from 3,247 of Year 6 children and 2,124 of Year 8 children. We can look at the figure. We see engineers is less than 30%, and from these samples, and for the scientists is more or less. So nurturing an interest in engineering earlier in school is a very critical step to build the healthy pool of students to graduate with engineering to enhance the economy in the future. The RESS aims and objective is to bring robotics engineering to schools, focusing on maths and science curriculum and starting from the primary school. To make the children enjoy learning through changing the way of many pupils and the staff look at engineering. And to attract and inspire the children to be creative, to improve their way of thinking, to come up with new ideas, new approaches, new solutions, and to let them think in the future of contributing and going to contributing and thinking of engineering field in the future. The RES aims and objective, or what I'm aiming to do, is to design an RES systematic book series, theoretical and practical, and this to be added to the national curriculum, in which, in my point of view, will cause a paradigm shift in the school of the future. So what I intend to do is to design for the theoretical part an RESS book for year 6, 7, 8, 9, 10, and 11, a lesson a week, and also to design for a book for the practical part is building, at this stage, building a robotic arm or that the children can assemble from scratch. This is for the practical part, and then I will explain it later at the end of this session. Now, why robotics? What is robotics? Robotics is a branch of engineering that involves design, manufacture, and the operation of robots. And also, robotics engineering overlaps with mathematics, science, computers, mechanical, electrical, mechatronics. Why do we use robots? It's obviously because they are quick, they can work all the time, they can work in a very dangerous and difficult places. And also, if we look for the robotics research and development focuses for the next decade, for medical robot, prosthetic, 19%, cognitive robots, 16%, intelligent vehicles, 14%, embodied intelligent, 11%, soft robotics, 8%, humanoid robotics, 7%, micro-nano robotics, 7%, brain-machine interface, 7%, wearable robotics, 6%, and defense, aerospace robotics, which is my specialization. My field of specialization, the aerospace robotics and cognitive robotics. A case study at Middleton Primary School, Nottingham. Before the idea came to my brain to start this idea of the RES project, there were, as a researcher, many questions that I was asking myself before starting this step. So the question is, how I'm going to help the children to engage in inquiries and ask a question about robotics. Then how I'm going to improve the teaching and learning methods and to make robotics, especially I'm studying a very difficult field, to make robotics something easy for teacher to understand that they can in a way deliver it to the students. Then how can I identify these challenges? And because I did my nursery and primary school in London, so this is myself, this is me at nursery school at St. Mary and primary school, primary school, and also I did the rest of my primary school in Iraq, in Baghdad, at Al-Bashar Typical Academy School. So in this case, I have the knowledge of both environments. So what the first step to do, I applied as a volunteer at Middleton Primary School, and they accept me for my research. I attended math classes, ICT, philosophy sessions, and then I was able to design and deliver 2 lessons. Modeling, the first one is modeling of inverse kinematics in a robotic arm and how to design a robotic arm in 2008. It was for the primary school, year 6, and Mrs. Lucy, she was the math teacher. The thing is, when I attended the math session there, the lesson was about angles. So the math teacher was teaching the children about the angles, different types of angles, acute angles, right angles, obtuse angles. She explained the lesson. Then she took the children outside in the garden, and then she started to ask the children, show me the types of the angles in the garden, like the trees, some kind, different types. And the children were saying, Miss, this is a right angle, this is the obtuse angle, and then they were showing her. So the question I was asking myself, how I'm going to link education between two quotations math with engineering between two quotations robotics. And then I asked myself, does the robot have an angles? Of course it does. And accordingly, I start to design my first lesson, and which I will explain it so quickly. I start with the inverse kinematics. What is inverse kinematics? It's the science of motion. And then I explain to the children, how are the robotic made? And what is the robotic? The robotic has a brain that processes information, software. It needs also moving parts to move, like actuators, wheels, and also it needs energy, like to use electricity, to use battery, oil and gas. And also when the robots use the brain, it gives the output in a way by using sensor like a heat, touch, whatever the sensor is. So inverse kinematic refers to the reverse process. Now, the main thing I have to focus in is angles, because they were studying at math. The curriculum was about angles, measurement, length. So the arm has base, upper arm, forearm, and hand. And whenever the hand is moved, there are different angles. And as well, I'm showing them the arm 1 and arm 2, which has also different length, different angles, and different measurements. And this is to link between the robotics and the math, where they are studying that the first arm, for example, we can call it L1 and L2. And again, the freedom of rotation and some duty or some task that the robotic can do or is programmed to do. And this is a picture of a robot girl. And the same idea was used by the engineer to design the arm of the robot. This is a prosthetic arm, and it has 4 positions, 1, 2, and 3, with different angles and length. The second lesson, it was about how we can design a robot arm and how can the robot arm scientifically be shown. So I'm showing them in the point of view of mechanical engineer that the robot arm is a mechanical device which consists of the shoulder and the other parts of the arm. And then this is a robot arm shown in this picture. This is from the engineering field totally. Then I'm showing them how this arm is assembled. It's assembled by, this is the robot base, and then link 1, link 2, 3, 4, 5, and 6. And this is the robot arm. So I did these 2 lessons, and I think how I'm going to deliver it to the children. First, I need to deliver it to the teacher, and then the teacher should understand it and then deliver it to the children. I had many meetings with Mrs. Lucy Dolby, and then we decided that she will deliver the lessons. So I handed the lesson to her. So the first thing Mrs. Lucy started, she started to explain the angles on a skeleton available at the school. She started to explain the movements of the arm before she started her lesson. And then the children, because they are children, so they start to do things like the robot is doing by the hand. And then she started to explain the lessons that she has delivered. She used here the protractor And she's showing that the robot is using angles and has similar movements and rotation, and that are mimic to the human beings. And then this is the other picture, so Mrs. Lucy started to ask some questions. Why do we need a robot arm? Some of the answers of the questions of this question is one of them answers is to replace a real arm if we have an accident, others said to do household things, others said to be used by disabled people, and these are the questions that the children start to think, why do we use the robot arm, and start to get out of the just man and to think about something related to engineering. And again, this is another picture. One of the questions, what are you seeing here in this picture? One student answered some of the human actual parts. And then there is another question. So she explained here. She explained that the mechanical device, and she pointed to the wrist, asking, what sort of attachment can be put on a head? And these are some of the answers. Some kind of a gripping, like a hand, pretty much anything like laser, a drilled answer, a third pupils, which is a very clever answer. So in this case, I linked between education, maths, which the topic of angles, measurement, length, and engineering, about the robotic as a mechanical device. Thank you. It's give me a great pleasure to introduce the next speaker, the educational consultant and advisor who was awarded the Lord Deering Award for her contribution to teaching and development. She was a leader of a project funded by the Center of Integrated Learning to encourage creative learning and teaching for undergraduate engineering and science students using a wide range of methods and techniques. Please welcome Mrs. Janice Yalomsky.
This is the bit I always like, the swap over. Creative STEM communication and education. Effectively, that's my job. How can I help other people creatively communicate science, technology, engineering, and mathematics? Now, I was asked to give you a bit of my background because I'm not a professor of astronomy. I am not a cultural attaché. I am not known amongst you. So really and truly, this is me justifying why I'm here and why Suhair has brought me along. I'm afraid I'm no longer bashful about my age. I'm 50 years old and I don't really worry about what people think about me. So I'm going to give you just a very short description of who I am. And I have to warn you now, I'm also a mother, I have 3 children, and I will have to depart, rather like Cinderella, at about 8:30. So I do forgive me if I exit, but hopefully you'll have questions to ask me later. My background is very eclectic. I have a chemistry background. I've worked in the construction industry. I've worked for a company that produced cleaning machines and chemicals. And because of my background, it often got me to do research. You know, how can we make this paint better? Who do you know what research has happened? So I often had to review and research other people's research. And it was in that company, I then moved on to being the PA to the technical director. He needed a personal assistant who actually could understand everything from engineering, chemistry, human beings, and keep his diary in check. So From there, I started working very much in the voluntary sector, working with people who are homeless, and I got interested in how we can enable and empower people, communities, and especially those who have been disempowered and those who haven't had chances. So I ended up training to be a teacher, a science teacher, and I really discovered I could teach. I loved taking really complex ideas and making them accessible for people. So, I mean, you can read on there, I've been a teacher of science, mathematics, I'm an education consultant. I got interested in why people couldn't learn, what was blocking them, what were the obstacles. I became a dyslexic consultant, looking at specific learning difficulties. And eventually, I wanted to understand more. Why was it young people in secondary schools were losing interest in science and engineering? So I went into middle school, and then I went into the early years, and wanted to try and work out what was happening to children's instinctive curiosity and creativity. So I taught everything from 2 years old to 82. I think it's the eldest I've worked with, 82. So I've worked across a whole range of people's ages and abilities. Having worked at Nottingham Trent University, I got asked if I would take out engineering projects. So the University of Nottingham asked me to work with Dr. McNally at the Institute of Biomechanics. And my work there resulted in various other academics, researchers, departments from engineering, chemistry, biology, but also the arts and humanities. Much to my shock, I even got asked by them to work with them on projects. So I've done a range of things. So I won awards. I don't normally tell people I won awards, so it's actually quite nice. Most recently, I won the Course Director's Prize for Research and Dissertation. I was told that my dissertation was abbreviated PhD, basically, and I won the distinction for that. I have, as quite nicely described, I've won the Lord Deering Award for my contribution to teaching and learning. And I have contributed both to, well, publications that I've done have been incredibly cross-disciplinary, from science engineering to philosophy, politics, sustainability. I've had to understand international economics. When you're working with education sustainability, it's not just being tree-hugging and ecologically minded, it's thinking about humanity, how can we work together globally, locally, looking at sustainability. So I've done quite a range of things. My current work, as I've just mentioned, I'm a mum. My husband works at sea. He's a senior master. He troubleshoots for OSM. And I have 3 children, one of which is on high-functioning autistic. And believe it or not, some of the highest areas that you will find autism, apart from the prison population, are universities and IT companies. And actually, when you're working with people at a high level, often their way of thinking can be a little bit single-minded. And it's very important that you understand how to work with people of all abilities, all mindsets, all thinking. I'm also a STEM ambassador and tutor. I do quite a lot within the community, so I'm very freelance, and I do a lot of helping people understand how to take A and bring it into B, how to help develop partnerships, how to communicate complex ideas. I was talking earlier, the importance of combining right brain and left brain, and making sure that there's balance, and making sure that it's accessible. And as part of my own development, I'm now a teacher of mindfulness and meditation. I'm also a specialist tutor for Clearlinks for Lincoln University. And my current project are these wonderful people in the local villages. The village has grown astronomically, the community is fractured, and there's a lot of mental health, isolation, a lot of generational gaps. So I've been asked to help set up a community development project. So I'm having to learn all about forest schools, how to bring children and adults together. So that's something I'm currently doing. And these are some of the wonderful volunteers. We now have, within 6 months, we had 90 volunteers, and we're now really developing that. My past projects, and this is how Suhair met me was through a project called Awesome Athletes, the science and engineering of movement for primary schools. It came from the Institute of Biomechanics, headed up by Professor Wallace, who's just retired from QMC. He's an orthopaedic consultant, and Dr. Daniel McNally. Fantastic people to work with. And I got to learn all about the movement of horses, rabbits, cats, dogs, humans, sparrows, you name it. I was having to learn all about the biomechanics and how you can translate that into things like robotics. How could we bring the body into schools and then take it next step further into engineering? What could we do? And my solution was to develop a legless 5-foot purple alien that was about so high the children could cuddle. And try to talk to a director of education to explain the project. And you start off, well, it all begins with Ambassador Zincroll, who's a 5-foot purple monopedal alien. And they do actually look at you a bit strange, but we gradually move on from there. And it is sometimes taking the unusual to help people develop creative ideas. Taking the robotics that we're thinking of now in Mars and what we're using in Mars, how can we get people to take it from their level of non-understanding to understand the concepts that take a robot to Mars and discover water? So, and why primary? Well, actually that's where enthusiasm comes past. Maybe most of you can remember something in your childhood that triggered you to be where you are today. And if you don't bring something in that's exciting in primary and young children's lives, how are you expected then to really key with them later? So this is what Awesome Athletes did. We did loads of workshops for newly qualified and trainee teachers. These are some of the works that they did. It's quite funny to see adults start to play with children's toys. We had undergraduate outreach projects. This was getting children to create little LED light bulbs and create patterns and shapes, and to get them to understand about electronics and things. This was to do with viscosity. This was one that went wrong. And this is what children were learning. They were thinking about viscosity. This was guttering, and they were thinking about how to create fluids that could drag and ripple and whatever. And then we're looking at how to protect an egg if you dropped it from 20 foot high up in the air. We had a whole range of professional workshops. We covered, this is the kind of things, we worked in over 70 schools in 3 years. I participated, led, facilitated and supported schools with their whole science fun days, massive. Took over the school, got staff involved, got children involved. And this is what we had great fun doing. They were all exploring their body, and from their body, what else? You know, thinking about movement, thinking about transport, thinking about disability, thinking about how we can make a hand like this become much more accurate in its function, and which we now know about surgery and doctors. This is Ambassador Zincroll. My children and I created that for primary. If you want ideas for primary, you go to children and ask. They will always think of something much better than you. And as adults, it's a lesson for us to learn. I learned the hard way. So they come up with some fantastic ideas. So these are the other examples of the project outcome for Awesome Athletes. We ended up working with the university on open days. We were supporting researchers and academics. And when I say we, it was predominantly me. And I'd have a cluster of my volunteers, train them, and then we'd get to work together. And in fact, I got asked if I would actually take on some funding to do some teaching. So this is one of the projects I delivered, and I don't know why that's there. It's the Awesome Wheels. I developed this. I was the principal investigator for this. I was the principal person running it. So I started developing things for the older children, the secondary school children, looking at transition. So we went from Awesome Athletes to Awesome Wheels and taking it on much further. So we started to include technology about pavements, roads, materials, impact. Here, this is where they were running their trucks down onto raw eggs. And they were seeing how well their buffers worked and their bumpers. And here are some more things. Awesome Athletes goes on the road. This was a big project for 13 and 14-year-olds that I developed. It was a whole day. They were there having to work and develop and test. Actually, it was 3 days, sorry. Master classes for young people at university, and this is the Settle project that I was also funded for. So while I was at the university, all of a sudden, I went from taking out a primary school project, and I was being headhunted across the university to take out a whole range of other projects and asking if I could develop them. And as I said just briefly earlier, my current project is the Village Project, helping them reconnect with their community, with the outdoors, re-establishing traditional skills. It's great going in the future, but if you haven't got the skill base, it's very difficult. And we're actually losing critical skills because people aren't connecting together. They're not connecting with the land, they're not connecting with communities. They're losing that sort of thing. So here's some of the pictures of the people in the church grounds. And this is and that's me. I'm actually still learning all about outdoor education. But again, it's bringing in the right and the left brain, taking big, whole, complex ideas and bringing them out into the community that people can understand. So, this is what I've been asked. I've been asked to be the education advisor and consultant. And it is actually a challenging area because one of the key things is that a lot of funding and a lot of space and time in primary schools has been squashed out. There's so many pressures now for teachers and children to tick the box and jump a hoop and get a qualification. And unfortunately, it's how can we get this into schools, get it embedded into primary schools. The idea of mathematics and science, but through robotics, a lot of the question is, well, I don't understand it. I don't even understand the mathematics. In primary schools, we've got a lack of people understanding maths and science, let alone applying it to engineering. There's issues of confidence in the staff. It's getting them on board. How can we help very busy parents who could skill teachers? How can we do this? And a big part of it is really sort of thinking about some of the complex and abstract ideas that we will have within robotics and some of the practical, and how can we creatively take these and bring them into school? How can we make the complex, abstract, the new, the boring? A lot of children think maths is boring. You may not think maths is boring, you may not think engineering is boring, but there's an awful lot of people out there who do. And how can we engage with them? And also making it accessible so the teachers aren't terrified. And having worked across hundreds of schools and worked with student teachers and teachers, there's a lot of fear. And maths and science, people are frightened, health and safety, you name it. I like working out how to do things, not how to problem solve. And one of the big things is how can we make it transferable? So Suhair's asked me, would I consider working with her to make the RES project interesting, accessible, transferable, and appropriate and applicable into our education system. So, as an example of how I would go about this, so the question for you, what are the concepts or connections between the Burj Khalifa building and a wedding cake that you could explore? This is how I work. So I'm throwing it over to you. We have a wedding cake and a 0.8 kilometre building. How would you connect those two? Why would I bring those to the table and say, I could teach engineering from a wedding cake?
Both trying to get higher.
Both trying to get higher. What else? Any other similarities?
The structure.
Structure, yeah. Does anybody know the main problem they had building that building? Foundations was one. And the wet. In fact, it's concrete. The biggest battle they had, can you imagine pumping concrete 0.8 kilometres up in the air? And in fact, each floor, every single floor, had to have a different composition of concrete because it gets hot. It can set in the pipes. Now, I built a garden. I spent 2 summers building a garden. And I got very passionate about concrete. And then I suddenly realised one day, it was just like working with icing sugar for a cake. Too humid, it wouldn't set. Too dry, it set too quickly. It would fracture, crumble, crack, splinter. And I discovered in my research with this particular building and in other buildings, having worked in the construction industry, I remember they used to do a slumber test. I'd like to have done it today. Get a circle, you tip a bucket of concrete upside down and watch it spread out. Depending on how it humps, spreads, it was too thick, too thin, a bit like Goldilocks. And you can do exactly the same with icing sugar. So I took the concepts from the Burj Dubai and related it to a wedding cake and used that as an engineering outreach project, using icing sugar. I like taking things that people say you can't do. I like being able to do something with it. And I enjoy working with academics and researchers from any discipline, which is why the University of Nottingham for 7 years brought me back in, working with their researchers and their postgrads, doctoral researchers, to help them understand how they can take their, you can't communicate that to a 5-year-old, oh yes you can. And I like taking it from engineering, mathematics, biology, physics, chemistry. I work right across the disciplines. And it's something that I think with the robotics, the potentials like the Burj Khalifa building, there is so much in robotics that you can take out and have fun with. So that's my sort of take, and that's me. So.
Now I would like to display a very short film directed by myself that links as well between engineering and education. It's called Al-Zahawi.
Army the robot that knows everything. Sarah wants to lose weight, but Sarah loves junk food. She loves to eat cakes, cupcakes, melted chocolate, candy, ice cream, donuts. While Sarah was walking and thinking for a way to lose weight by counting calories in junk food, she decided to set a plan for herself, in which she was determined to stick to it. Suddenly, Sarah met an object. She felt scared. The object introduced himself to her and started to have a chat with her. Hi, I am Arnie, the robot. I know everything. I am glad to meet you. I hope you are ready to talk with the artificial intelligence. I am Arnie, the robot. Sarah was afraid to talk to him. In case you are afraid, you can still talk to me. I know everything. What kind of robot are you? I am like a human that stores data, knowledge, and information in my brain. You have to keep talking to me. I know everything. What should I? That is what I was programmed by engineers to do. I don't know what you are talking about. You said you know everything. I do know everything. Prove that you know everything. Okay. How? Tell me how much calories based up in 22 grams of fat. 427.141 calories. How did you know? What are you? Are you a man? No, I know everything. Is that a yes? No, is an organized collection of data, knowledge, and information. Engineers store the data base in the robot brain in the form of tables, such as shown in the sandwich tables, which has total fat and total calories. How did you know the amount of calories? Based upon 22 grams of fat is 424.141 calories. Do you want me to explain how? I am me, the robot. I know everything. Okay, how? My brain uses the bit of line mathematics topics. Engineers store the maths in my brain. My brain follows the steps. Then I explain to Sarah the steps of the best fit of the line. To prepare a scatter plot of the data, plot the points, choose the points 9, 260, 35, 530, or can choose any different points. Calculate the slope of the line through the two chosen points, as shown in the figures, and write the equation of the line. The final equation can now be used to give the value of the points that was not plotted in the scatter plot. The total calories in 22 grams of the fat is calculated as such. The final answer is 427.141 calories. Ari the robot advised Sarah to count total calories in food or even in junk food, eat healthy and exercise in order to lose weight. Arnie the robot was happy to meet Sarah and would like to meet her again. Arnie the robot promised to help Sarah to reach her target. Sarah was excited and so happy to meet Arnie the robot. The video gives an information that the robot is an artificial intelligence machine. A robot is mimic to the human, storing data, knowledge, and information. A robot is programmed by engineers to provide answers. Robot can store huge amounts of data compared to human. Engineers store mathematics and robotics brain. And also the video gives an information about the mathematics topics, such as collecting data topic page 2, GCSE, maths, organizing data topics page 4, GCSE maths, and line of the best fit topic page 198, GCSE maths, and ours is to encourage the new generation to count calories, eat healthy, and exercise. Thank you.
Thank you very much. I would like now to explain about the RESS practical part. So the practical part of the RESS project is building a robotic arm, and the children need to bring this robotic arm starting from the scratch. After they build the robotic arm, it will be like that. It can be linked to the computer, it can be programmed manually, and I'll explain it all by programming. So the first thing, this is my first stage to start with this. But I have many ideas for the RES project, but this is the first step. So if I open the box here, here I can see 6 bags filled of parts. Some have plastic pieces, some has motors in, and some has more stuffs inside bags. Can a child assemble this to make a robotic arm? Of course not. Even if it is somebody who has not, who doesn't have an engineering background. So if I open the bags, this is the parts, and this is the manual. I would like to show you the manual that is used to assemble the robotic arm. As I can see that it is not easy for our children. And as well, we study this, we call it engineering drawing in our first year, to learn how to draw shapes. But my aim is I would like the teachers to learn and to teach the children how to assemble a robot. So in this case, what I have, the interest, or I would like to do books for that. So the first thing, if I open, this is the parts. If I go for A, so where is A? A is here, 2 of them. This is B, that B. This is C. C is that one. And this is D, is that one. So now it is easy. Now the other one, E. This is the manual, this is my work. This is E, where is E? That one. And this is F. Where is F? Is that one. Now, if we look at this mechanical parts, let's go for the P1. P1 is motor. Quantity is 2, has 2 wires, orange and the black. So we now know what P1 is. It is here inside P1. P2, it is another motor which has a blue wire and a black wire. We have 2 of them. If I say I want P3, P3 is another motor. We have 10 in the quantity washer and the color is gray. And we have 5 gears and the color is brown. And here the color is blue. And this is output, gears, output, and we have shifts, we have as well tapping, and we can see that we have different kind of tapping, and all of them is together. So the child or anybody who is not an engineering background will see it difficult. But we know that we have, for example, this tapping, it has different length. So my aim. Start first how to build a robotic arm. I just will start with the first step because it needs the time if I assemble it now. So we have the first thing is to assemble these 4 gears, folks. We assemble one and the others is the same. I bring a piece of paper, and I put the parts that I need to assemble them. So I need these parts, that one, and this is the cover, and I need a blue washer, and these kind of parts, I need them. And I took a picture to each one to make it easy. Now, we go for this is the manual, and this is what I have to explain. So the first step, if we put this, part like that, and again, we add the blue washer over the gray washer, and over the blue one, another gray. And again, over the gray, we put another orange. And then as you can see, we can see the explanation here. We can see there is a slots here, and we need to put a nuts. And the nuts can be put here, and the way to put it can be explained. But it is very easy, but we have to know the way. Again, we need to put the motor like that one, which has a color-coded wire, the orange and the blue one, and then we cover it. I show you at the first we have 2 covers. Then I need now 3 screw tapping, and I want them to be 10. So the child will learn to measure the tap. I have to put them there. Finish. I need to do a lot of screwing, which is not difficult. We need to buy these, which is not difficult, and now finish the 4-gear box. So I think this is easy and to understand if I make it in this way. This is for the gear box, but I'm not going to continue how to assemble the others because I'm going to make it easy in my book in the future. This is the base of the arm, and at the end we need to assemble the robot to be like that, and then we can program it to do many for many applications. Now coming to the, just have an idea about programming. We can link it to a program after we assemble it. So there are two modes for using it. There are the basic one, and the basic one you can link it, and then you will have the program one. We come to the basic one. The basic one, we can use the mouse. So I can use the mouse to move it here, and we have, this is the mouse, and this is the light. And I can change the mood by using the keyboard. So I can use the keyboard as well to work with it. Also, the advanced one is to teach the children to program it and write the program that they want. So this is for using the program. Now, till now, I explained in my presentation about the robotic arms and things related to a robotic arm and how to assemble. Let us go to the real world engineering fields. See how the real engineering are assembling or doing the robotic arm and for which task. Please see this very short film.
Which has bored human beings to death. Robotic arms have varying degrees of freedom, meaning they can pivot in different ways. A robotic arm resembles a human arm. It has a shoulder, an elbow, a wrist, and a hand. The shoulder is actually a stationary base to which the rest is attached. An engineer first designs all the parts on a computer. Then those plans go into action. To form the base's outer casing, they bend steel sheeting into shape using a computer-guided press. Next, they paint the casing in powder paint using an electrostatic process that guarantees a thorough, even coat. They run a negative electrical charge to the casing and a positive charge to the paint particles. This makes the casing draw the paint to it like a magnet. Once the paint on the base casing dries, they use silkscreen printing to apply what's called the user diagram. It illustrates which parts move where and how. Now they build the robotic arm's hand, called the end effector. Robots can be outfitted with all sorts of end effectors. Here they're making a gripper, whose two claws come together to grasp and carry objects. To make each claw, an automated metal drill cuts a groove lengthwise and widthwise in a piece of aluminum. They assemble the electrical circuit board that will later go inside the base. The robotic arm's 6 separate motors will plug into it. Next, they assemble the mechanical parts of the base. First, the motor that makes the arm rotate. Then the gear that goes on the vertical shaft holding the robotic arm upright. When the motor makes the gear and the shaft turn, the robotic arm turns with it. At the arm shoulder level, they install a system of 4 pulleys. Each consists of 2 plastic wheels on a separate axle, with a rubber belt running between them, like a clothesline. The belt has little teeth that grip grooves on the wheels. It rotates the wheels, making the robotic arm move. Each joint in the robotic arm is capable of and programmed for a specific range of movement. Like the human arm, the combination of these movements manipulates the end effector. They plug an electrical wire that links the gripper to the shoulder into a circuit board located in the shoulder. Then they screw the entire arm to the base. They link up the wires from the circuit board in the base to the motors in the shoulder. To do this, they have to bunch the wires, 48 of them in total, and thread them through the shaft that attaches the base to the arm. Once everything's connected, they fine-tune and test the gear connected gear system that operates it. Turning the gear one way opens the grip. Turning it the other way closes it. Now they mount the assembled gripper to the forearm, plugging its motor into a circuit board that they've already installed there. They plug the wires from all 6 motors into the main circuit board, which they then install on the back of the base. The robot controller, the brain that runs the arm, is a separate unit. It controls everything connected to the circuit. To move the robot, the computer inside the controller switches on all the necessary motors. It can control 8 motors, 6 in the robot, and 2 optional accessories. You can program it to perform a variety of tasks. From start to finish, it's taken just under 30 hours to assemble this robotic arm. It can lift up to 10 pounds, about the weight of a full-grown cat, and it can move at a speed of a little over 1 mile per hour. Most robots are reprogrammable, meaning that to change their behavior, you simply write a new program. From an employer's perspective, robots may be the ideal workers. Granted, they have no ideas of their own, but their productivity is constant. They never call in sick, and they never take lunch or coffee breaks.
Thank you very much. Now I would like to start with the RESS panel discussion. I would like to introduce Mrs. Janice Yaron, the Educational Consultant and Advisor, and Dr. Amar Sagban. We'd like to cover an issue as to whether the RESS can play a role in improving the number of people in the engineering field, or what kind of role that the RESS project could play or should play for the future schools, primary and secondary school, and how it can be achieved. I would like to open the door for the questions. If anybody has any questions or any idea, any feedback that it can help.
Well, first question. I just want to ask Mr. Omar. Do we, in Iraq, in the education system, do we have robotics in school, in the syllabus? I'm saying this because when I was Suhair's age, I was in Baghdad years ago, we tried to put astronomy in the syllabus of the teaching in Iraq. And everybody said, what do they need astronomy for? The stars and all this thing and the planets. Now, of course, everybody says, well, you learn about the movement of the planets, you know, about the gravity and about the laws of this. So now, this robotic topic is very important. First, how much in education in Britain is the robotics in school, in high school, in GCSEs, A-level? Yes. And I wanted to know about Iraq and how does it work?
Yes, okay. I don't think there is any project like this in Iraq, but our game to put this in the new system of education. This is the goal of our project. But in England, I don't know really.
It's very patchy. It depends on the school, depends on who's driving it. At primary, for example, 10, 15 years ago, there was a number of projects going out that was like equipping schools with little tiny little robots about that big, which children could program to go left and right. But the problem is, in primary, there's a lot of teachers that aren't confident, so these things are being left on the shelf. I went in with microscopes, the microscopes that we put through computers and in cameras, and they just get on the shelf because primary school teachers didn't always have the confidence to use it. In secondary, in the last few years, there's a real push to have computer programming in the syllabus, especially at secondary. But it's not necessarily being linked to robotics. It's virtual. So they're computer programming a little creature on the screen to move. So the Awesome Athletes project was one of a kind in its day, when for about 4 years they were looking at the biomechanics of movement and looking at the engineering of movement, and robotics started to come in, hence Suhair's interest. But the funding wasn't continued because there was a change. And again, unlike Iraq, where you've got a free education program all the way through to doctorate, which I'm totally envious of, that has lost. We've lost a lot of that in this country. We have free education, yes, but there's a lot of caveats. There's a lot of we've got many different kinds of schools, and some schools are working one way, some schools are working another. So whereas you can work maybe with the whole of the education system, we would have to work it on a more piecemeal, and there are options of how we would link it in, and that would have to be researched. The possibility is you look at the national curriculum and you make it national curriculum driven, or you create projects which schools can take up and use on a cross-curricular basis. So there are different ways of approaching it. Robotics in this country, it's patchy.
My question to the panel is it wise to indoctrinate our children at this young age about robotics? Because, you see, they lose the best years of their life, their innocence. You see, it would be one of those things which we have learned when we were children. So is it wise, or is it better to leave it to some other time when they get a bit older?
The issue, as I show you in the first slide, we have 0% children passionate to go, aspire to go for engineering, and for year 8. So in this case, if we are not going to start to move from now, we will not have most of the generation will not inspire to go to such a field of engineering or field that scientific fields. So we need to start from now. For this reason, the RESS project is to add a lesson to the new curriculum, to the new national curriculum, as one lesson that I intend to design a book, one lesson a week for theoretical and for the practical. For this reason, this will make the children to think. Even for a girl will not. As me, I am a girl, okay. I will never in my mind come and use a screw, for example. If a child, she will play with doll and princess, and the boy will play with cars, okay? But I will think to buy these unless I am an engineer. So if we start now, we will attract more girls to come to engineering. Now we don't have, like even in Iraq when I was 4 with me in my class, just 4 girls and all of them are boys. And now what I'm seeing, most of the children, they are not thinking at all of being an engineer. So if we add this, if we inspire them, and as you see, I show you a case study, and they come with a very brilliant idea, and this is what we need. This is our goal. I will leave the Janice to.
I think what we were talking about earlier about balance and how we approach it, and I think that's the important thing. Suhair contacted me literally just a few weeks ago, so I've been putting my head around it and thinking very much the same thing. We have lots of children who are sitting there on computers, and everything is done for them, and curiosity is not there. They don't ask the questions to how is it working, what do we do. It's like we automatically assume that if we switch the light comes on. We don't ask where it's come from. So there's an awful lot of non-curiosity. So I would say robotics could be useful in primary by getting children, regardless of gender, playing with screwdrivers. And in fact, I'm sure you're all aware here in the UK, unfortunately, we have got what I call an overwhelming pink culture for girls. It's getting worse. In fact, I think it's worse now than it was when I was a child. And we are the social media, the television, we're promoting very stereotypical ways of doing things, which is really sad. And in fact, a lot of children are being asked to be consumers and end users rather than creative, innovative, take things apart. My son loved, when he was a child, taking apart radios and binding all the bits, and he cut his fingers and then he tried to screw it back together, and he discovered that some things you could screw back together, some things you couldn't. And we're losing this kind of tactile, interactive curiosity. So I think if a child was basically introduced to the robotics by building and constructing and having fun with screwdrivers, and it may not even be starting to build those arms, it could literally be encouraging teachers to realise that health and safety does not exclude sharp things and screwdrivers. You can actually get kids to make things again that require screwdrivers and cuts. Sharp scissors, not the blunt scissors that they give them, but sharp scissors. So I think it's how you do it, in what context you're doing it, but also I think there's a danger that if you have a programme and it's implemented like a plaster all the way through, it could get boring. And it may go, well, it was really interesting to begin with, but fourth year down the line, is the same similar lesson, similar format going to be interesting? So it's going to have to be how you do it, how you approach it. It's going to be you have to think it through so that it's engaging, asking questions, getting hands-on, interactive. And it may be at primary level very, very, very basic. Just like with the awesome athletes, it was exploring their body, looking at how you could make an arm move. How do you make it move by swing? So it's making all those baby steps and making it fun. And I think a big thing is making it fun.
My question really is creativity inborn or is it taught?
Both. I think you have to give the space. I think it can be creative. I think some people are naturally more creative, but I think you can create spaces for creativity, and you can give children the skills and the language to develop creativity.
You agree with me that people are different?
Yes.
Their levels are entirely different from one person to another. So creativity really depends on the age of the person. So you have to assess the person before you introduce this robotics.
Yes, and I think there's going to be a lot of assessment going on, because from Suhair has an idea, but already we've started to take it apart and go, well, that bit's suitable for that age and that bit's suitable for that age, and actually we can't put those two together. That needs to be there and there. So it is a case of what you see is an idea, but it's not necessarily context appropriate for the age. So there's going to be an awful lot of taking apart and reassembling into something that's more appropriate.
For your concern, I agree with you. But when we started to use the computer, also we had this concern that could be a replacement of our mind, our way of thinking. And also that's also searched by a medical team one day before, when they started to use the robotic engineering during the theater with surgical interference, and they said would be replace the doctor or the surgeon. I think the balance between them is very important.
Yes, thank you very much for your nice presentation. Actually, we have reported to the Minister of Education in Iraq about the subject of robotics, hoping that the Minister will take that into effect to some schools in Iraq rather than all schools, because it's difficult to now to make it general for all schools, primary or secondary or intermediate school in Iraq. We have to choose to select some schools for this subject. But unfortunately, of course, no answer until now is given to this subject. But I think this is very important. But we have to start with training some teachers to how to teach or how to present the subject to the students in the primary school or in the secondary school or even at universities. So I think we have to plan, set a suggestion or proposal for and simplify it so that the people in charge in Iraq they can take it into action if they see a simplified way of teaching, because this is actually a new methodology of education, a new methodology of teaching and education, rather than the traditional methods of teaching in the schools. So I think if we put some proposal, simplified one, and then we have to present it again to the Minister of Education and Minister of Higher Education in Iraq, and we have to follow this subject until we get a successful approach. Thank you.
Thank you very much, Professor Al-Zahawi, and I will will put a plan for it and a proposal, and we'll send it to you.
Simplified.
Yes.
Yeah.
Thank you. Is there any feedback, question, any new idea?
Well, me again. We have at the UCL, every department at UCL got outreach officer, a person who is involved. For example, physics and astronomy, we have somebody with a PhD. His job is to contact schools or people who are interested in, say, physics and astronomy. I mean, ideally, I would suggest to Suhair if she could be in an outreach department of a university in robotics. That would be great for her if she gets involved into robotics through university outreach. This would be perfect. I mean, I'm saying this because today I received an email from King's College Robotic Society, just accidentally, just today. They sent me next week they're having a meeting, a group gathering for members, and they have members from all backgrounds. And they say, don't worry, we're going to start from the beginning, no prior knowledge. So they try so you don't get frightened, because they think robotics is very difficult. So I think I would suggest, to Suhair or others would be go to King College next week. I'll forward the email to you. And they're going to have a lab for 3 hours to assemble things. And they say, don't worry, this. But also, I think if you can work in a department, in a robotic engineering department as an outreach person in charge, that would be wonderful.
Yeah, I would agree. I think in this country, the way the education sector has gone from early years all the way up to university, and the way the funding has gone, for example, like the EPSRC, Royal Academy of Engineering and things like that, is that they used to actually have funding specifically for outreach, but I think it's changed. So anybody now doing any kind of funding, PhD, is expected to do an element of outreach. So it's making the university and the departments have to really want and have and lobby for outreach officers. In some universities they're better than others, some colleges are better than others. So at the moment, within the UK, the playing field is very bumpy. It's knowing who and what, where and when. This would have been 10, 15 years ago an ideal project which would have been funded out in schools over a period of 3 or 4 years. Now you're having to look at it slightly differently, and I've suggested to Suhair that it might be something that she would, rather than write everything straight off, but to actually work in partnership with either a exam board such as OCR, or working with the publishers that are linked. So it could be something that or even working with some of the more media, so like the BBC or the educational television programmes, where they could take on the ideas. So Suhair would have the concepts and the national curriculum, and she would work in partnership. So I think in the UK, this is why I can't say I'm the project coordinator, because Iraq is so different to how we're working here. And so it would be a case of doing research, it would be linking up with groups, but if you're making it into a viable, self-sustaining, financially sort of self-sustaining as a project, that maybe you have to put a more entrepreneurial head on it. It might be that working in conjunction with the company who produces the arms, it might be that they would work with her and finance, etc. So there's going to be, so at the moment, I would say in the UK, it's working at the basis, and it's working with people like yourselves, people who can actually see the gaps, advise connections, but also helping sort of with your expertise in using the robotics in space, using robotics in surgery, using robotics. So I think in the UK, it's a different playing field with a different approach required. Does that sort of give us a better idea about it here?
Just sort of quick, not really quick, a long list of questions. They could be interconnected. I'm going to play a devil advocate for the questions. I'm going to start with where you ended. I think Iraq and the UK, they have completely different drivers, different needs. As you rightly mentioned in the charts, there is a requirement for engineers in the UK, but I'm not sure there is a requirement for engineers in Iraq. If you ask any Iraqi what they want to be, either a doctor or an engineer, that's the first. So expectations of the family is different. And if you look at the UK, I was interested in one of your charts because economics is the first one. Maybe I think it is. I don't think it is interesting, but the incomes high. I mean, it could take a civil engineer 10 years to reach a graduate of economics in the first year of income. So, is it about how interesting it is, or is it about how money savings will progress in my life? That's the different issue. So that's number one. Number two, I'm not sure if robotics is a good representation of engineering. Engineering is a huge variety of fields. Could the child be attracted to Burj Khalifa more than a robotic arm, maybe? I don't know. That's a question for us to think about. How do we attract people for engineering? Maybe robotics is too complicated, as you mentioned. Maybe it's still interesting, I don't know. I'm just asking a question, maybe it's somewhere else we can
I think it's more interesting than engineering. I think robotics, yeah.
As a civil engineer, I would never give it.
I think there's room for all sorts of things. I think I think this would be very much looking at robotics, but you could also bring in materials, you could bring in the idea of how people have actually automated. It's simple things like laying roads. Now, yes, I quite agree, a civil engineer, the forces and the interaction of road surfaces, and why does the road tarmac wrinkle up the side of the road, and why does it split in the middle where you don't drive on it? You know, all those kind of really weird and curious questions. You know, I can understand that you can go down various avenues of engineering, and each area would have really fantastic areas that which you could research. You know, fracture mechanics is marvellous. Now, I'm not an engineer, I'm a biochemist, but I've ended up getting very curious about fracture mechanics. Why is it when I was laying the slabs in my garden, did certain slabs split right down the middle and other ones chunked? I think if you can create a curious, questioning mind through any means, and children love things that move by themselves. They are fascinated, you know, and I think if you can help them understand how it moves by itself, what it can do, then you've got those questioning minds going on. I agree, there are areas about robotics that are really going to be challenging to bring into primary, and I think the awesome athletes, the lessons that have been learned from there would help pull it in. It's things you could actually, with robotics, bring in civil engineering. Like, you've got the robots on Mars. The terrain that those robots have got to go across, they've had to try and work out what that terrain is and find a place here on this planet. So you're looking at geography, geology, you're looking at testing that. Does it actually work? You know, if we're going to drop a robot onto the ground, well, it's like dropping an egg from the ceiling to the floor. How do we do it? If the atmosphere is thin, if it's windy, how do we work it? So I think there's scope here for some fantastic stories and role-playing. And some of the best science and engineering I ever did with children was in a room with bits of paper and some rubber on the floor, and they were using their bodies and felt tips, and they were answering questions, and all they were doing was thinking and talking. So it doesn't have to be as complex as what we've seen here. You can take it right back down and just use their bodies, the floor, and a pen and paper. So I think, and then you can start thinking, well, the robot's got to move on a surface. What's the surface going to be like? How are you going to create that? What do you do? So I think this is just an idea. It's a question. How can we get robotics? How can we get people engaged in engineering? Because engineering is a multidisciplinary subject. You know, it's literally, you have to read, you have to write, you have to be creative, you're problem solving, you've got your mathematics, your design, your science. There's so much in engineering, and it's a shame that it's not been exploited fully into schools. So I think you can do it, but I think you're right, it's where it's taking it from.
Following on the suggestion of the professor here, for Dr. Suhair to start with the Iraqi community here, to collect a few Iraqis who are interested in the field, rather than going to companies and universities. To start with, you form a nucleus of possible society, if you like, of robotics, Iraqi robotics or something, and then you start from there, as a body, not as a person.
Well, it is a very good idea, thank you very much, but for the theoretical, I'm looking for focusing on the math and science curriculum to link it with the robotics. And why did I use the robotics engineering? Because this field specifically overlaps with many fields, with the math, with the science, with the ICT, mechanical, electronical, and many of these fields. For the lesson that the first presentation you saw that I present, I spent 3 months in the school to see how children react. Then I start to have many meetings with the teacher, and then after many discussions, she could present these 2 lessons. To make a curriculum, to make a book, that what I am suggesting, that I have to have many ideas and many research to do. And I think it is a good idea to have link with the Iraqi community, especially. But I don't think we have a robotics very. And now in a society of robotics that I can link at this stage.
You form one.
This is what I'm thinking, to form one. Yes, I have think of that one, of this idea, and I am trying to put my first step for that, especially for my research.
You know, there is Iraqi Engineering Society,
Yes.
where you can establish special interest groups in society. So they have different groups. This could be a robotic group.
Actually, we invited representatives of some schools here, Iraqi schools, but nobody actually come. And regarding your question, Mr. Muntala, I think it's a good idea to let our children play with this robot instead of weapon. Yeah. Could be developing, but at least not using for fighting each other.
I have a suggestion as well. So in the UK, I've been in touch with the Institution of Mechanical Engineers, because that institution is massive, and they do loads of activities with the schools. So I'm pretty sure they can support you, and yeah, probably the STEMnet as well, because they have guides for ambassadors who go to schools, and this material could be very, very good for that.
Thank you very much. Any other questions? Okay. Okay, so we have to come to the end of the seminar, and I'm deeply grateful for the cooperation of all participants. Again, thank you very much for joining the RESS seminar today. Thank you very much.
Thank you.
Thank you.